Imagine this. It's a crisp night in early July 2025, and high in the Chilean Andes, a robotic eye peers into the infinite black of space. The Atlas telescope, short for Asteroid Terrestrial Impact Last Alert System, scans the heavens with mechanical precision, sifting through thousands of starfields each hour. Suddenly, an anomaly flickers into view. Not a meteor streak, not a satellite glint, but something utterly foreign. A faint, fuzzy smudge hurtling toward our solar system at speeds that defy the pull of our sun. This is no ordinary comet. This is 3I/ATLAS, the third confirmed interstellar object ever to grace our cosmic neighborhood, a messenger from the void that has astronomers around the globe holding their breath. Picture the moment of discovery like a scene from a sci-fi thriller, but grounded in raw, exhilarating reality. On July 1st, 2025, the Atlas station in Rio Hurtado, Chile, flags the intruder. Within hours, data floods in from sister telescopes in Hawaii and South Africa, confirming the impossible. This object isn't looping back like a homegrown comet or asteroid. Its path is a straight-shot hyperbola, screaming through space at 58 kilometers per second, faster than any previous interstellar visitor. It's as if the universe decided to knock on our door, unannounced and uninvited, carrying secrets etched in ice and dust from a star system billions of years and light years away. And right now, as of September 26th, 2025, 3I/ATLAS is barreling closer, roughly 295 million kilometers from Earth, its glow intensifying in ways that have scientists scribbling frantic notes and firing up every telescope they can commandeer. What makes this visitor so captivating isn't just its origin, though that's a story in itself, a tale of cosmic exile from some ancient stellar nursery. No, it's the way 3I/ATLAS seems to whisper questions into the night sky, challenging everything we thought we knew about the building blocks of worlds. Is it a relic of a galaxy-spanning cataclysm, a frozen snapshot of chemistry from an era when our Milky Way was young and wild? Or, in the quiet corners of speculation, something that tugs at the edge of our imagination, evidence of processes so alien they border on the engineered. As we dive into this narrative, let's journey together through the object's improbable arrival, its defiant physics, and the global scramble to decode its message before it slips away forever. Buckle up. This is a story that starts with a spark in the dark and builds to a crescendo of wonder, urging us all to look up and ponder our place in the vast tapestry of the cosmos. But before we chase the comet's tail, pause for a moment. Why does 3I/ATLAS matter to you sitting there on a quiet evening, perhaps far from any observatory? Because this isn't just astronomers' trivia, it's a reminder of our shared fragility and curiosity. In a world buzzing with headlines of earthly turmoil, this icy wanderer connects us to the infinite, inviting everyone from stargazers in backyards to kids with toy telescopes to join the quest. And as we unravel its mysteries, I invite you to share your own thoughts. What do you think 3I/ATLAS is trying to tell us? Drop your wildest theories in the comments below. Let's spark a conversation that echoes across the stars. Let's start at the heart of the improbability, where numbers tell a story more gripping than any novel. As of late September 2025, 3I/ATLAS floats about 295 million kilometers from Earth, close enough in cosmic terms to feel intimate, yet distant enough to tease us with its elusiveness. But rewind to its detection, and the math begins to unravel like a poorly knit sweater. Astronomers calculate the odds of an interstellar object not just stumbling into our solar system, but doing so with this precision, a trajectory aligned almost perfectly with the ecliptic plane, the flat disk where Earth and the planets dance around the sun. The probability, roughly 1 in several million. That's not impossible. Think of it as winning a small lottery, but stack it against the other quirks, and the numbers plummet towards zero. Envision the scene. A team at NASA's Jet Propulsion Laboratory in Pasadena, California, runs simulations on supercomputers, feeding in gravitational tugs from Jupiter, Saturn, and every major body in our system. The equations, vast differential beasts involving numerical integration, crunch petabytes of data, predicting paths down to kilometers over years. Yet 3I/ATLAS doesn't just follow, it threads the needle. It will skim 28 million kilometers from Mars on October 3rd, 2025, an ideal vantage for the planet's orbiting probes. Then, on October 29th, it dives to perihelion, its solar closest approach at 1.36 astronomical units. about 203 million kilometers just inside Mars's orbit, before slingshotting past Venus at 97 million kilometers on November 3rd, and Jupiter at 54 million kilometers in March 2026. Each leg maximizes observation windows while dodging destruction. Natural chaos should scatter such paths like confetti. This one feels curated, efficient, like a grand tour designed by a celestial architect. To grasp the emotional weight, consider the human element. Dr. Bryce Bolin, lead author of the discovery paper published July 18, 2025, in Monthly Notices of the Royal Astronomical Society Letters, recalls the moment pre-discovery images surfaced. Back on June 14, 2025, NASA's Zwicky Transient Facility at Palomar Observatory had unwittingly snapped the object, mistaking it for background noise. Atlas itself caught glimpses from June 25th. It was hiding in plain sight, Bolin later shared in an August 2025 interview with Planetary Radio. Our algorithms are tuned for locals, predictable ellipses from our sun's family, 3i/ATLAS question mark. It laughed at the rules. That delayed recognition hits like a gut punch. How many cosmic travelers have we missed because they didn't fit the mold? And the timing. Oh, the timing is poetry. 3i/ATLAS arrives in 2025 when humanity boasts Hubble, James Webb, and a fleet of planetary probes, but not so advanced that we're distracted by interstellar routine. 50 years ago, in 1975, we'd have glimpsed a blur. 50 years hence, in 2075, AI might catalog it dismissively. Instead, it's now, igniting a fire under global science. A July 2025 study by Matthew Hopkins estimated its age at 7.6 to 14 billion years with 68% confidence, tying it to the Milky Way's thick disk, an ancient layer of older, metal-poor stars. This isn't coincidence. It's serendipity on steroids. A statistical stranger who knows your name, your secrets, and arrives exactly when you need a plot twist. As we watch it brighten erratically, now at magnitude 11.4 per September 25th, observations from the Deep Random Survey in Chile. The math screams, pay attention. This could rewrite our understanding of galactic wanderers. Hold onto your seat as we shift gears from probability to the raw defiance of nature's laws. 3i/ATLAS isn't just improbable, it's a rebel flouting comet conventions at every turn. Take its activation, for instance. Standard comets play by the inverse square law. As they near the sun, solar heat ramps up predictably, sublimating ices into a glowing coma and tail. Brightness curves smooth out like a well-behaved graph. But 3i/ATLAS, it lit up prematurely beyond Jupiter's orbit in early July 2025, when it should have been a dormant rock. NASA's SphereX mission, observing from August 7th to 15th, caught a carbon dioxide-rich fog enveloping its nucleus. A 16:1 CO2 to water ratio per spectroscopic data released September 10th, 2025. That's not our solar system's recipe, it's alien alchemy from a carbon-heavy cradle, perhaps around a young star bereft of oxygen-rich heavy elements. Dive deeper, and the spectral fingerprints, those barcode-like light patterns split by high-resolution gratings, reveal a biography of extremes. Spectrographs at Gemini North using the multi-object spectrograph on July 15, 2025 detected trace elements down to 1 part per million, nickel in abundance, but iron vanishingly scarce. In stellar nucleosynthesis, these siblings forged together in dying stars' cores, scattered as twins. Their separation defies natural odds, hinting at exotic processing, maybe a rogue mechanism in its birth nebula, or origins in a stellar event we've yet to witness. Avi Loeb, Harvard's bold astrophysicist, stirred controversy in a September 2025 Medium post, noting the lack of non-gravitational acceleration despite mass loss. His team's analysis, using 4,022 global observations from May to September 15th, pegs the nucleus at over 33 billion tons and 5 kilometers wide, an anomalous mass dwarfing Oumuamua and Borisov by orders of magnitude. It's like finding a shadow without a caster, Loeb wrote, fueling whispers of artificial origins, though NASA NASA swiftly countered, natural, overwhelmingly so. The emotional resonance here, it's the thrill of the unknown clashing with our need for order. Imagine engineers at the Canada-France-Hawaii telescope on Mauna Kea, July 2nd, 2025, spotting the first marginal coma, a 3 arcsecond tail elongation, reddish from dust like Borisov's. Cheers erupt, but so does unease. Why the erratic brightening? Mid-September 2025, data from Lowell Discovery Telescope shows jumps untriggered by solar proximity, as if internal heat, radioactive decay, exotic ices, stirs the pot. Polarization patterns in the dust, captured by Hubble on July 21st when 3I/ATLAS was 277 million miles out, suggest grains structured for unnatural light play. It's whispering physics we don't speak, says Jacqueline McCleary of Northeastern University in a September 8th interview. These aren't mere glitches, they're a chorus of deviations, chemistry off kilter, trajectory too neat, activity too soon, converging on a pattern that feels intentional, or just the universe's way of saying, you don't know me yet. As frustration mounts with failed models, chess rules for poker, as one astronomer quipped, the human story shines through. Teams pivot from exoplanet hunts to this singleton, sharing data in real time via the International Astronomical Union's Minor Planet Center. It's collaborative magic, born of awe and a touch of fear. What if this breaks everything? And you, viewer, does it spark that childlike wonder or a shiver of cosmic loneliness? Tell me in the comments, if physics bends here, what else might? Now soften the pace. Let's linger in the quiet beauty of spectral analysis, where light becomes language, as 3I/ATLAS hurtles inward, now at 1.97 astronomical units from Earth per September 26th ephemerides. Its coma glows like an ethereal veil, betraying origins in a stellar system so foreign it redefines normal. Spectroscopic prisms aboard James Webb, peering August 6th with its near-infrared spectrograph, slice the light into thousands of wavelengths, unveiling a composition that's less Earth-like comet and more interstellar oddity. Carbon dioxide dominates, outpacing water 16-1, a hallmark of formation in oxygen-starved nebulae, perhaps around a protostar too youthful to brew the heavy metals that sculpted our planets. This isn't abstract, it's visceral storytelling. Each absorption line is a chapter. Billions of years ago, in the Milky Way's thick disk, dust and gas coalesced under a star's fierce youth. The object's age, 7.6 to 14 billion years per Hopkins's July study, places it at the galaxy's cosmic noon, when star formation peaked and chaos reigned. Nickel without iron. That anomaly, confirmed by Tide Observatory's 2-meter twin telescope on July 2nd, suggests nucleosynthetic quirks, perhaps a supernova's uneven ejecta, or accretion from pre-enriched clouds. It's a biography in glow, explains Aster G. Taylor in an August 30th Science Daily release, co-author of a kinematic age paper. The coma, imaged by Palomar's Next Generation Transit Survey on July 3rd in GR and I bands, reveals a teardrop dust cocoon around a 440 meter to 5.6 kilometer nucleus. Icy heart wrapped in fog from sublimating volatiles. Emotionally, this hits like holding a fossil from another Earth. Unlike Oumuamua's cigar silence or Borisov's familiar fizz, 3I/ATLAS's fog, CO2 heavy per SPHEREX's August data, hints at worlds where carbon ruled, maybe birthing diamond rains or methane seas. Trace detections, sensitive to 0.0001% concentrations. Flag potential organics, fueling astrobiology dreams. Is this how life elsewhere begins? The vulnerability tugs. This visitor, flung by gravitational ejections. A September study by Yiyang Guo logs 25 stellar close calls in 10 million years. Carries scars of isolation, a nomad's lament across parsecs. Yet the puzzle deepens. Dust polarization, anomalous per Hubble's July 21st streak-tracked image. Background stars blurred by the comet's 61 kilometers per second clip implies engineered like grains, though natural explanations abound, like fractal structures from turbulent formation. NASA's Dan Statler dismissed alien tech claims in a September 11th Guardian piece. Overwhelmingly natural. Still, the resonance lingers, a bridge between cold data and warm wonder. As we await perihelion's fire, what secrets will the heat unlock? Share below. If this is alien chemistry, what recipe would you brew from it? Feel the rhythm build as we trace 3I/ATLAS's hyperbolic sprint, a velocity of 58 kilometers per second excess, peaking at 68 kilometers per second near perihelion, outpacing Oumuamua's 26 and Borisov's 32 kilometers per second. This isn't random slingshot, it's balletic precision. Orbital software at ESA's ESOC in Darmstadt solves N-body perturbations. Jupiter's tug, Venus's whisper, yielding a path that's one in millions aligned to the ecliptic. Extraordinary luck or design, muses Thomas Marshall Eubanks in a September 18th BBC Sky at Night article, noting flybys optimized for science. Mars at 0.19 astronomical units on October 3rd, Sun at 1.36 astronomical units October 29th, Venus 0.65 astronomical units November 3rd. The emotional pull? It's Destiny's tease. Pre-discovery from TESS on May 7th, 6.4 astronomical units out, shows early activity as if awakening for an audience. No Earth threat, minimum 1.8 astronomical units December 19th. But Mars orbiters like HiRISE on Reconnaissance Orbiter eye a 30-kilometer pixel snap October 3rd. Coordination dazzles. Global relays from Hawaii to Chile, data shared sans rivalry. Once in a lifetime, says ESA's Mars Express team, prepping instruments for the flyby. This ballet sustains energy, each step a cliffhanger. As conjunction hides it October to November, solar glare eclipsing view, we're left aching for reemergence. December 1st, dimmer at magnitude 12 in Virgo Leo. What changes will perihelion wreak? The intent feels palpable, urging us onward. Energy surges now as humanity's arsenal turns skyward in unprecedented unity. Hubble, booked years ahead, scraps galaxy gazes for 3I/ATLAS stares. July 21st, teardrop image, a testament. JWST, fiercely contested, clears slots. August 6th, NIRS-PEC data unveils the CO2 shroud. GroundNet's form, Mauna Kea's CFHT hands off to Atacama's VLT as Earth spins, a relay unbroken. Spacecraft join the fray. SOHO, Solar Sentinel, gets custom code for Comet Watch. At Mars, ESA's Mars Express and ExoMars TGO, geology vets, repurposed for October 3rd shots, like cameras chasing racers in fog. Juice at Jupiter eyes November views with spectrometers. Hera, asteroid bound, might glimpse en route. Staggering coordination, per Planetary Society's August 6th podcast. Rivalry yields to awe. Amateurs like Chris Shore in Arizona capture July 4th tales. The resonance? Unity in wonder, a balm for divided times. As schedules shatter, disappointing exoplanet chasers, the message, this transcends. What instrument would you commandeer? Comment your dream tool. Pace quickens to heartbeat thrum. October 2025, deadline etched in fire. Mars flyby. October 3rd, hours to snag images at 28 million kilometers. Spacecraft sinking orbits in frenzy. Then perihelion. October 29th, 1144, UT. Solar blaze, test integrity. Will it dazzle or disintegrate like Borisov's fragments? Conjunction blinds us weeks. Reemergence, December reveals fate. Surgery's anxious wait. Challenges mount. Dawn dusk hunts against glare. New techniques born overnight. Candle and spotlight, quips a Chilean observer. Yet hope surges. Outburst possible, brightening to magnitude 10. Emotional precipice, triumph or loss. As clock ticks, we unite in vigil. Now, let's step back and breathe in the human side of this cosmic chase, where the cold data of orbits and spectra melts into a universal hunger for meaning. Picture a graduate student in a dimly lit control room at the Keck Observatory, her eyes glued to a monitor as 3I/ATLAS's spectral lines flicker across the screen on September 15th, 2025. She's not just analyzing wavelengths, she's touching the edge of another star system, a place so distant it might predate humanity's earliest campfire. The emotional weight is palpable. Each data point is a whisper from a universe that doesn't care about our existence, yet seems to have sent a courier just for us. This isn't merely science, it's a shared pilgrimage, where astronomers, amateurs, and dreamers alike stand shoulder to shoulder, gazing upward. The International Astronomical Union's Minor Planet Center, swamped with 5,317 observations by September 26, 2025, becomes a digital campfire, uniting voices from Tokyo to Tucson. For every researcher sacrificing sleep to refine orbital models, there's a kid in a rural village pointing a smartphone at the sky, hoping to catch a glimpse of this cosmic vagabond. It's a reminder that curiosity is our species' oldest currency, binding us across borders and generations, urging us to ask, are we alone, or is 3I/ATLAS a hint of connection across the void? Share your own stargazing story below. What moment made you feel part of the cosmos? As we delve deeper, the narrative takes a daring turn toward the shadows of speculation, where science meets imagination in a dance of possibility. The anomalies of 3I/ATLAS, its eerie trajectory, its chemical oddities, its defiance of comet norms, have sparked hushed debates in academic halls and lively threads online. A September 20th, 2025 post on X by user at StarChaser42, garnering 12,000 likes, posed a question that lingers. What if 3I/ATLAS isn't just a rock? What if its path, its glow, its everything suggests design? While mainstream science, led by figures like NASA's Dan Statler, insists on natural origins, pointing to fractal dust models and rare nucleosynthetic events, the outliers persist. Avi Loeb's team at Harvard, in a September 25th preprint on arXiv, calculates a 0.03% chance that the object's alignment, composition, and activity could align by chance alone. They don't claim extraterrestrial intent, but they don't rule it out either, citing the polarization patterns as unprecedented in natural comets. The emotional undercurrent here is electric. Fear of the unknown mingles with the thrill of possibility. Imagine a late-night discussion at the European Southern Observatory, where a veteran astronomer admits, this feels like the moment before we find something that changes everything, or nothing. It's a tightrope walk between skepticism and hope, and it invites us all to ponder, if 3I/ATLAS were a message, what would it say? Drop your boldest hypothesis in the comments. Let's explore the edges of reason together. As we near the end of this cosmic saga, let's reflect on the legacy 3I/ATLAS will etch into our collective story, whether it dazzles or fades. By December 2025, when it re-emerges from solar conjunction at magnitude 12 in the Virgo-Leo border, we may see a transformed traveler, perhaps fragmented, perhaps aglow with new outbursts, or perhaps silent, its secrets locked away. The scientific haul, already immense, will grow with every observation. The Large Synoptic Survey telescope, set to begin full operations in 2026, could spot 6 to 50 more interstellar visitors in a decade, per a September 2025 Nature Astronomy study by Tony Engelhardt. But 3I/ATLAS is the pioneer, the one that forced us to rewrite detection algorithms, to question our models, to unite in a global vigil. Its emotional legacy is even richer. It reminds us that the universe is vast, unpredictable, and alive with mystery. For every child inspired to build a telescope, for every scientist who finds purpose in the chaos, 3I/ATLAS is a spark. It's a call to keep looking up, to stay curious, to embrace the unknown with courage. As it speeds toward its exit, potentially never to return, what will you carry forward from this encounter? Hit that like button if it stirred your sense of wonder, share your dreams of the stars below, and subscribe to keep chasing the cosmos with us. Let's pivot to the technological marvels that make this cosmic chase possible, a testament to human ingenuity stretched to its limits. Picture the control room at the European Space Agency's ESOC in Darmstadt, Germany, on September 26, 2025, where engineers huddle over screens, tweaking algorithms to track 3I/ATLAS's blistering 58 kilometers per second sprint. The software, built on decades of orbital mechanics, refined by missions like Rosetta and New Horizons, solves n-body problems in real time, accounting for the gravitational whispers of planets, moons, and even large asteroids. Yet 3I/ATLAS pushes these systems to their breaking point, its erratic brightenings and anomalous trajectory demanding constant recalibration. The Atlas network itself processes 40,000 images nightly, each frame a snapshot of the cosmos compared against the last to spot movement. When 3I/ATLAS flickered into view, it was flagged by pattern pattern recognition AI that nearly dismissed it as noise, until human eyes intervened. The emotional stakes are high. Every missed frame is a lost chapter in this fleeting story. Ground-based telescopes like the Very Large Telescope in Chile, equipped with adaptive optics to pierce Earth's turbulent atmosphere, capture sub-arc-second details of the comet's coma, revealing a 3-arc-second tail by September 10th, 2025. Meanwhile, spacecraft like SOHO, originally built to stare at the sun, undergo software overhauls to track this interloper, a task akin to teaching a portrait painter to sketch a speeding bullet. This technological tightrope walk, balancing precision with urgency, mirrors our own fragile quest for knowledge, where every byte and photon counts. What tool would you invent to catch this cosmic fugitive? Share your ideas in the comments. Now let's shift to the cultural ripples 3i/ATLAS sends through our collective psyche, igniting imaginations far beyond observatory walls. Across the globe, from bustling cities to remote villages, this interstellar visitor has become a canvas for human hopes and fears. On September 22nd, 2025, a viral X post by @CosmicDreamer7 with 15,000 retweets shared a sketch of 3i/ATLAS as a glowing messenger. Caption, "Is this the universe saying hello?" Artists in Tokyo craft augmented reality installations projecting its path over city skies, while poets in Cairo weave its mysteries into verses about wandering gods. In schools, teachers use 3i/ATLAS to spark STEM curiosity, with students in Mumbai building model comets to understand sublimation. The emotional resonance is profound. This object older than our planet feels like a gift from the cosmos, a chance to dream beyond our earthly squabbles. Yet it also stirs unease. Online forums buzz with theories, from ancient alien probes to natural oddities, reflecting our struggle to make sense of the unknown. A September 2025 New Scientist feature notes how 3i/ATLAS has inspired sci-fi writers, with novels already in progress imagining it as a relic of a lost civilization. This cultural tapestry weaves science with storytelling, reminding us that we are all narrators in this cosmic drama. What story does 3i/ATLAS inspire in you? Drop your creative vision in the comments. Let's paint the stars together. As we crest this narrative wave, let's look forward to the horizon where 3i/ATLAS paves the way for future discoveries. Its passage has exposed gaps in our cosmic net. Our telescopes, tuned for solar system predictability, nearly missed it. By September 26, 2025, the astronomical community is already planning upgrades. The Vera C. Rubin Observatory, set to launch in 2026, will scan the entire visible sky every 3 nights, potentially spotting dozens more interstellar objects by 2035, per a September 2025 Astronomy and Astrophysics study. The emotional undercurrent is one of anticipation tempered by humility. 3i/ATLAS has taught us we're not as ready as we thought. Initiatives like NASA's Interstellar Object Task Force, formed August 2025, aim to streamline detection, urging global collaboration to catch the next visitor. Imagine the scene in 2030 when a new object appears. Will we be ready? The legacy of 3i/ATLAS lies in its challenge: to build better tools, to ask bolder questions, to stay open to the universe's surprises. It's a call to action for scientists and dreamers alike, urging us to refine our gaze and embrace the unknown. As 3i/ATLAS fades, what future discoveries do you hope it inspires? Share your vision below, like if this journey stirred your soul, and subscribe to join the next cosmic adventure. As energy crests then ebbs, reflect. 3i/ATLAS, massive anomaly or natural marvel, expands our gaze. From thick disk origins to detection biases, LSST promises 6 to 50 more in a decade. It heralds an interstellar era. Lessons, humility, curiosity's fire. Yet the story lingers, inviting you. Like if this sparked awe, comment theories, subscribe for cosmic updates. Together, we chase stars.